Okay. This is lesson 1-5, second set. And to get that in there, I'm going to go up and clear it. Dennis, you can just watch me. I'm fixing to do it again. Okay, so you're going to go to the y equals button and hit math, which is right under alpha, and then arrow over to numbers, and that's number 1 for absolute value. And see how my cursor's inside? And then you're just going to hit the xt theta n is fine, and then arrow over, and you have the absolute value of x. Okay? Now it says to move to y2 line, move to the y2 line, and then press vars, enter, or arrow, enter, enter. So let's do that. So we're here, hit the vars button, which is right next to clear. And then it says hit the arrow over, so you're going to go over to y vars. Okay, and then hit enter for function and enter for y sub 1. So we're taking y sub 1 and then we're going to do something to it. Okay, so this will place y sub 1 in line 2, enter a number to translate the function, then press graph. Okay, so let's do this one. Let's put in plus 4. So plus 4 and enter. Now let's hit graph, which, you know what, this is not a good, let's go back. Hit y equals, we're going to have to go to zoom number 6 for the standard viewing window. That's going to make a whole, we had a different thing in there for whatever class that was. Okay, so notice it graphed the parent function first, and then it graphed what we did to it inside. Now, if we wanted to do this next one right here, this is g of x equals the absolute value of x plus 3. So here what we're going to have to do is this. Let's go here and let's clear out our y equals. So here we're going to have the absolute value of x, so math over to number 1, absolute value of x. Okay, now we want to do, I'm going to say parentheses, absolute value of x plus 3. I think I can do that. Well, can I do that without, let me try. Okay, so math number, absolute value is 1. Okay, so we're just going to do x. Now in this case, I think, can we do what they said before? Let's try it. Y bars 1, enter, plus 3. Outside the function, oh no, I meant to say parentheses, sorry. Okay, I think this is correct. So y sub 1 plus 3 within the absolute value. So let's hit graph and see what happens. Oh, praise the Lord, pass it to you. Oh no, it still went up. Okay, it didn't work out right. So let's go back to this, go down. I'm going to clear that out. We're going to have to do the whole thing. So math, go over to numbers, 1, absolute value, x plus 3. Arrow over, and where should graph now? Yes. And notice how plus 3 moved it to the left. Right? Okay, good. Is everybody clear? Crystal, glass, darkly? Mud? Where are you? You okay? It's not? Okay, well, let's get to that in a minute, okay? Because I'm going to run out of time. Okay, and we've already seen those. Now, if you notice down here at this one, and I won't take the time to graph it, but the translations have happened. Here's the parent graph, the blue, and so it's moved down 1, and to the right 2, 1, 2, and then the red line is the translated graph. Okay. Now, you need to be able to do those, not just with absolute value functions, but with any function. Here's to the third. okay? And that's going to, you know, look like the sway of the wave, one end going up on the right, one end going down the left. And then, you know, we've just moved the whole thing down 5. Here, we moved everything to the what?
Right.
The right 3 and what here? Left 2 and up 4. Is everybody getting that? Okay, praise hallelujah. So if I can get through here, I think you guys will be okay for tomorrow. Okay, in Jesus' name. Okay, let's move on back up here. Okay, another type of rigid transformation is a reflection, which produces a mirror image of the graph of a function while with respect to a specific line. Okay, now remember, this is translated down, you know, just flipped over the x or y line, depending, and there's your two reflections over the x-axis or the y-axis. So if you have, and we did this before, I think, g of x equals negative f of x is the graph of f of x reflected over the x-axis. When g of x equals f of negative x, it is the graph reflected over the y-axis. Okay. All right, so let's look at this. We'll see examples. Hopefully that will make real good sense in a minute. When writing an equation for a transformed function, be careful to indicate the transformations correctly. The graph of g of x, this is the opposite of the square root of x plus 1, or minus 1, plus 2, is different from the graph of negative, or the opposite of the quantity, the square root of x minus 1 plus 2, end of quantity. Okay? So this one would look like, okay, so if you had your parent graph, would do this number, right? So if it, number 1 is going to move up 2 and to the right 1 and then reflect over the y-axis because it's following, or the x-axis, it's following this, the horizontal anyway, is what it's going to reflect over at that point. So that's negative f of x. But, let's go over here. Now, this graph is, you have to do this first and then reflect it. So, we are going to go to the right, I'm sorry. Oh, this negative would be transferred, oh, I'm sorry, I'm saying something different. But this negative would be translated into both of these, or distributed, I'm sorry. Do you see what I'm saying? That negative needs to be distributed into each term inside the parentheses. So that would make this negative 2. So that would go down 2 to the right 1, and then reflect over the horizontal. Okay, good. Okay, now, it says, let's do some describing here. Describe how the graphs of f of x equals x squared and g of x are related. Then write an equation for g of x. Okay, so here we go. This is a parabolic shape. So, right, what's our parent graph to a parabolic shape? X squared. Y equals x squared, right. The graph of g of x is a graph of f of x equals x squared. Okay, that's the parent graph. And it's translated 2.5 units to the right. Okay? And then, what else is happening? It's translated 2.5 units to the right, and then what? Okay, so let me draw this. If we have, I love to draw my parent graph in a dotted line. So if we have this parent graph doing this number, right? Okay, you don't have to draw it real perfect, just get it on there so you can kind of see it. Now, this one is 2 units to the right, so that would be 1, 2, so it would look like this, right? And then it's going downward. Okay? I'm just going to do it real sloppy, but sorry. So, I don't know if you can see that very good. I'm sorry. So, here's where it was. It moved to the right 2, and now it's going downward. So, that would take us from f of x equals x squared. To the right, we're going to have to add 2, right? So, f of x equals x squared plus 2. But then we've got to account for the whole thing going downward. Okay, so the whole thing going downward. You know what? I just did something wrong. I'm translating up. Whoopsie. You have to tell me when I'm wrong, folks. I'm okay with it. Okay, so it's to the right. We're inside the function, right? So that's going to be the quantity x squared. I'm sorry, I did it again. The quantity x minus, is it 2.5 or just 2? I think it's 2. Squared, right? But it's going downward, right? What?
We couldn't see it.
Oh, sorry. Silly me. Okay, so that's this one. Moving to the right 2 units. Do you guys agree? But now it's reflecting across the x-axis or the horizontal. So g of x has to equal negative of the whole thing. Okay, that will reflect it across the x-axis. So then the final verdict is g of x is going to equal negative, can you guys see that? X minus 2 quantity squared. All right? Are you okay with that? Okay. Now, so how did they say this? The graph of g of x is the graph of f of x equals x squared, translated 2.5 units to the right. Oops, I just did 2. Sorry, 2.5. So 2.5 units to the right and reflected over the x-axis, or in the x-axis. So g of x equals negative quantity x minus 2.5 squared. Yes, no, maybe so. Okay. Okay, so what's happening to this one? What's happening to this graph?
From the parent graph?
So the parent graph again is x squared, right?
Yeah.
So we know, where's the vertex moved? Up 2. So we know that's a plus 2 on the outside, right? And then we are flipping it down. It's reflecting over the horizontal. So, so we are taking the opposite of the function, which 2 was not in the function, right? So we're just taking the opposite of the function. That's still, I'm sorry, reflecting over the, no, that's right, the x-axis. Okay. Does that make sense to everybody? Okay. All right. Now, let's see. I think, what time is it? Somebody can tell me? Oh, so the bell's going to ring. So we've got, you guys just have 3 pages to get through. We got through 4. And Ronnie's going to look over those tonight, and then he's going to go over this tomorrow with you. And then it's going to be on YouTube. And I'm going to put this on YouTube. And then I don't know if what he's going to do is going to be on YouTube, but this will, in case you need to watch it again. Okay, thanks for watching. Sorry, it gets crazy. Okay, bye.